Who knew how a beach ball-sized metal ball would change history forever? Today we'll be looking at the world's first artificial satellite. Here I will cover its history, its mission, and its aftermath. We shall also see the birth of the Soviet space program and subsequently the space age. So without further ado, let us go. Here is Sputnik 1. The idea of man-made objects orbiting Earth did not necessarily formulate in the 20th century. Sir Isaac Newton's Philosophiae Naturalis Principia Mathematica, published in July 1687, which is nearly 270 years before Sputnik, has his famous cannonball thought experiment. To put it simply, it says that a cannonball launched horizontally from a hypothetical tall mountain at a fast enough speed would continue circling the Earth instead of flying away. It wasn't necessarily an idea to launch satellites, but was the first mathematical study of orbital motion. Fast forward to the 1860s with the short story known as The Brick Moon by American author Edward Everett Hale. It contains the first known depiction of the launch of an artificial satellite, but this time it's a brick sphere 200 meters in diameter intended for navigational aid. Now we arrive in the 1900s with the birth of modern rocketry. Here we meet Konstantin Tsiolkovsky, one of the most important people in modern astronautics, and whose writing would inspire the Soviet space program. In his treatise Exploration of Outer Space by Means of Reactive Devices, he describes a multi-stage fueled rocket being used to launch spacecraft into orbit. He even derived an equation to describe the motion of rockets. As we get closer to the 1950s, people have been looking for ways to make this idea into reality, and this is where we get to Sputnik's origins. Let's go to the 1930s for a bit. Here we meet Ukrainian engineer by the name of Sergei Korolyov. Inspired by Tsiolkovsky's works and dreaming to one day go to Mars, he and Baltic German rocket enthusiast Friedrich Sander founded the Grupa Izuchenia Reaktivnego Divizhenia, or GIRD, to study and conduct experiments relating to rocketry. By 1933, they had launched their first rocket, GIRD-9, which had reached 400 meters in the air. By late 1933, Leningrad's Gas Dynamics Laboratory and GIRD had merged to form the Reaktivny Naučno-Isslедовательский Institute, or RNII. By now, Soviet missile technology now equals German rocket technology, but progress would be brought to a screeching halt when Joseph Stalin, leader of the Soviet Union, initiated his Great Purge to rid the nation of his opponents. Multiple leading engineers were exiled, and Sergei Korolyov himself was arrested by the NKVD in 1938 for allegedly slowing the work of his research institute. He was later sent to a gulag, or Soviet labor camp in Siberia. In late 1939, his sentence would be reduced to 8 years in an experimental design bureau, or Sharashka, which is basically a labor camp for scientists and engineers. He and other engineers, such as rocket engine designer Valentin Glushko, would finally be discharged under a special government decree. Korolyov would be commissioned to the Red Army in 1945, where he would earn a badge of honor for developing rocket motors for aircraft. When World War II ended in the same year, Korolyov and other rocket experts were brought over to the now occupied and devastated Germany to recover an important piece of technology, the V-2 rocket. The V-2, or Vergeltungswaffe II, was the first ever guided ballistic missile developed by Nazi Germany to attack Allied cities to avenge the bombing of German cities, hence its name, which meant retribution weapon. The rocket was actually the first man-made object to pass the Kármán line, which defines where space begins, about 100 kilometers in the sky. A bit unlucky for the Soviets, the Americans had already taken the leading German rocket scientists, including Wernher von Braun, who was the leading designer of the V-2. The Soviets still did get a hold of over 2,000 German rocket engineers and experts, Helmut Grottrup and Fritz Karl Preichschat. On 13th May 1946, Stalin signed a decree making missile development a national priority and established NII-88, or Science Research Institute 88, based on an island northeast of Moscow and under the military control of Dmitry Ustinov. Ustinov then appointed Korolyov to become the chief designer of OKB-1, which specialized on long-range missiles. Soon enough, they would be working on a complete replica of the V-2, which was designated as the R-1 and was first tested in October 1947. The tests proved how unreliable the V-2 was, and so Korolyov's group began designing an improved version known as the R-2. The R-2 had double the range of the V-2 and was the first rocket to utilize a separate warhead. Next was the R-3, which would have had a long enough range to hit the United Kingdom, if it weren't for the fact that it was cancelled in 1952 because Valentin Glushko couldn't get the required thrust on his RD-110 engine for the rocket. Meanwhile, Korolyov joined the Communist Party, where he would then request money to work on further projects such as the R-5, which would have a successful test flight by 1953. From here, we now put our focus on the R-7 rocket, which will begin its life as an ICBM. Design work for the rocket began in 1953 with the requirement of a two-stage missile with a range of 8,000 kilometers that can carry a 3,000 kilogram warhead. The final design won't be approved until 1954 after Korolyov had reviewed over 100 design proposals. The rocket is obviously very different from the previous ones. The basic structure of the rocket is the core stage, named Block A, and 4 strap-on boosters, named Block B, V, G, and D. At launch, the engines of the core stage and all 4 boosters ignite as the first stage until the strap-ons use up all their fuel and detach in a fashion known as the Korolyov cross, while the core stage continues firing as the second stage. The side boosters are powered by the 4-chamber RD-108 engine, while the core stage is powered by the RD-107. The two are related engines, with the main difference being the number of vernier thrusters which are used to steer the rocket. Both engines are designed by Glushko's OKB-456. Test launches didn't begin though until 1957. They will be launched at the new Scientific Test Range number 5, a missile range founded in 1955 near the village of Tyuratam in the heart of the Kazakh steppe. This missile range is actually what we know now as the Baikonur Cosmodrome. As an ICBM, the R-7 had a very rough start. Its first flight on May 1957 deviated from the nominal flight path by about 12 kilometers and crashed 3,200 kilometers downrange from the launch site. Subsequent flights were only slightly more successful or a complete failure entirely. Its most successful flight, launched on August 1957, had the dummy warhead disintegrate 10 kilometers over the Kamchatka Peninsula. Despite this, it was still presented as a success by the Soviet media. 2 months later is when it would debut as a space rocket, but first let's rewind back to 1954. Let's move away from Korolyov a bit to talk about a man named Mikhail Tikhonranov, the Deputy Chief of Science Research Institute 4, or NII-4. He had been trying to make multi-stage rockets or packaged rockets into reality since 1947 to make unlimited range missiles. His research onto this would soon evolve to making a rocket which can launch orbital satellites. He had been keeping it underground during Stalin's era, but when Stalin died, Tikhonranov thought it was finally safe to initiate the satellite project in NII-4, so they did in 1954. The findings of this project would soon come to Korolyov and made it the basis for proposals on launching Earth-orbiting satellites. When the proposals were presented to the Soviet Politburo, they were initially uninterested. It wasn't until 1955 that the Politburo would accept the proposal, when American President Eisenhower's press secretary announced that the US would launch a satellite during the International Geophysical Year. Thus, the Sputnik program was born. The word Sputnik is actually just a general word for satellites in Russian, and is not only the specific name for Sputniks 1 and later 2 and 3. It literally means fellow traveler, like how satellite came from the word satel, which means companion. By 1956, the Soviet Council of Ministers approved practical work on a satellite dubbed Object D, which intends to have instruments to collect data for future Earth orbiters. But because the object was so complex, it could not be launched in time, so OKB-1 suggested building a small, light satellite with a simple radio transmitter instead of the heavy science equipment, so that the Soviets had a higher chance of beating the Americans to it. The Council of Ministers approved the satellite designated Object PS, prestigious Sputnik, which means little satellite, and just we got the satellite we know as Sputnik 1 today. Object D won't be scrapped though and will be launched as Sputnik 3. The final satellite for Sputnik 1 would be a 58.5 centimeter polished ball covered in a 1mm thick polished heat shield. Inside will be 3 silver zinc batteries which power the satellite's radio transmitter and temperature regulator systems. The 4 whiskers on the satellite were its whip antennas. As planned by Korolev, the satellite will be launched on top of a modified R-7 rocket, which replaces the warhead and missile guidance systems with the satellite payload. The satellite is protected by a cone-shaped fairing during launch and is ejected when the satellite is deployed. On the morning of the 3rd of October 1957, the R-7 rocket carrying Sputnik 1 was rolled out from the assembly building at Site 2 of the Scientific Test Range No. 5 to Site 1-5. The rocket began fueling on the next day, October 4th, which will be when it launches. Skipping ahead to T-15 minutes, the access gantries surrounding the rocket were lowered. Then, at 22:28:34 Moscow time, the R-7 lifts off from the launch pad to join the stars in the night sky. At T+16 seconds, a fuel regulator would fail, causing excessive fuel consumption and threats higher than normal. This would cause final engine cutoff to occur a second early. At T+1 minute and 56 seconds, the Block B, V, G, and D strap-on boosters separated from the rocket, while the core Block A stage continued firing and flew normally for the rest of the flight. At T+4 minutes and 55 seconds, final engine cutoff occurred 228 kilometers from the surface. Around 20 seconds later, or at T+5 minutes and 14 seconds, Sputnik 1 separated from the fairing and booster stage at an orbit of 224 kilometers by 247 kilometers, inclined at 65 degrees relative to the Earth's equator. The spent rocket stage would stay in orbit, sending telemetry data to the ground until December 2nd, when it fell back to Earth and burned up due to orbital decay. Meanwhile, Sputnik 1 had activated its transmitter shortly after separation from the rocket. The signals from Sputnik were first detected at the IP-1 tracking station, which sounded like a series of beeps. Soon after deployment of the satellite, the Telegraph Agency of the Soviet Union would announce, as a result of great intense work of scientific institutes and design bureaus, the first artificial Earth satellite has been built. On the 26th of October, 326 orbits later, Sputnik's batteries would run out and stop transmitting. The satellite would re-enter Earth and be destroyed on the 4th of January 1958 after completing 1,440 orbits.
CBS Television presents a special report on Sputnik 1, the Soviet space satellite. Douglas Edwards reporting.
Until 2 days ago, that sound had never been heard on this Earth. Suddenly, it has become as much a part of 20th century life as the whir of your vacuum cleaner. It's a report from man's farthest frontier, the radio signal transmitted by the Soviet Sputnik, the first man-made satellite as it passed over New York earlier today.
Though it may seem weird to us now that people in the West US were scared over a small metal ball with a simple radio transmitter, there were genuine concerns. The launch proved the range of the R-7 rocket, which, if you remember, was originally made as an ICBM. Furthermore, the Soviets hadn't released images of Sputnik until 5 days after launch, which meant that the US didn't know what it looked like. For all they know, it could have been a Soviet spy satellite. And of course, the thought of American education lagging behind the Soviets, which would be a big propagandic blow for America. While most of the public was terrified or thrilled if you were a science enthusiast, President Eisenhower wasn't saying that it did not raise his apprehensions. It was only a scientific achievement and not a military threat. But he was still concerned. He still thought that the Soviet scientific superiority would be used to undermine America's leadership and superiority, and that they would eventually pose a real threat once they made a large enough military presence in space. Overall, Sputnik spurred many initiatives in the US, ranging from defense-oriented to education-oriented. America, now wanting to catch up to the Soviets, launched their first satellite, Explorer 1, a few months later on January 1958, atop a modified Redstone missile known as the Juno 1. It would also be the catalyst for the formation of both the Advanced Research Projects Agency, now known as DARPA, and the National Aeronautics and Space Administration, NASA. For the Soviets, meanwhile, Sputnik 1 was the last of their launches. On 7th of December, Sputnik 2 was launched, but this time carrying the first mammal into orbit, a dog named Laika. She would sadly die during the flight. As mentioned, the original Sputnik, Object D, was not put to waste and was launched in Sputnik 3 in May 1958. The R-7 rocket, though historic as the first ICBM, would prove to be very impractical as a missile. The rocket was expensive and required big launch pads. The Soviets could only have 10 at a time, and furthermore, these launch pads were just easy targets to be destroyed. The R-7 ICBM would be phased out by 1968. It would still find a place in spaceflight and would host a multitude of historic missions. A new stage was added on top of the rocket to launch the first lunar probes. Luna 1 would be the first satellite to reach the vicinity of the moon, and Luna 2 would be the first to reach the surface. It would then evolve to the Vostok L, which would launch more dogs into space. Korolev Sputnik 2 would be the first to send animals into orbit and back on the ground safely. Next was the Molniya rocket, which would launch various satellites, such as one also named Molniya and the first Venus probes, Venera. Then the Vostok K, which would launch the first humans in space. This was the rocket of Yuri Gagarin's historic Vostok 1 flight, German Titov's Vostok 2 flight, which was the first time man spent a day in space, and Valentina Tereshkova's Vostok 6 flight. Then there was the Voskhod variant, which launched Voskhod 1, the first spaceflight with more than one crew member, and Voskhod 2, which had the first ever spacewalk. And the most recent evolution of the R-7 would be the Soyuz rocket, which is now known for launching the Soyuz and Progress spacecraft to space stations, most notably the International Space Station. It is considered to be one of the most reliable rockets, and modern variants are still in service now. And after that, the rest is history. NASA on the other side of the world would go on to do their own space programs like Mercury, Gemini, the Apollo program, and the Space Shuttle. And eventually, both sides would set aside their differences and achieve great things. All started by one small metal ball. That's it for now. Thank you for watching.